A triangle is formed by connecting the points, and it gives us some coordinates, 3, 0, 0, 4, and the origin. And we want to find the volume of the solid that's formed by rotating that triangle around the y-axis, and then we're going to do it again around the x-axis and decide which of those solids has the greater volume. Now, I guess I would say a lot of people would look at this problem and go, I'm pretty sure they would be the same. But you're about to find out that is not the case. Alright, so let's maybe draw a picture for this first one here, rotating around the y-axis. I'm going to just estimate where these points are, so let's say that's 3, 0, and then we're going to go up 4, so maybe just a little bit higher here, so 0, 4, and of course the origin here. So there's my triangle. Let's color it in. So if I rotate this thing around the y-axis, it's going to generate a cone. If you can picture that cone there. And its parts are, down here, this is going to be the radius, this 3 is the radius. And going up here, this 4 is going to be the height, h equals 4. So remember that the formula for the volume of a cone is 1/3 pi times the radius squared times the height. And we have all of our pieces, so we just plug them right into the formula, piece of cake. So the volume is going to be 1/3 times pi. My radius here is 3, 3 squared is 9. Let's put it right in there. And the height is 4. Okay. And then rather than just multiply this all out, I can go ahead and take 1/3 of 9, and that's 3. So if I multiply this, I get 12 pi units cubed, or cubic units. Okay, so that's the volume of the cone that's generated whenever we rotate it around the y-axis. Now let's do the same thing, except for around the x-axis here. So same kind of triangle here. So I'll just kind of shortcut this a little bit, because we know that this part is 3, this part is 4. This time we're going to go around the x-axis, and our cone is going to be generated this way. If you can picture that one. Okay, so this time down here, that 3, it's not the radius anymore, that's our height. Okay, and over here, our radius equals 4. So perhaps you can see that just switching those two numbers, is it going to make a difference? Let's see. Alright, so our volume is 1/3 pi r squared times the height. Our radius here is 4. 4 squared is 16 this time. And then our height is 3. So I can just take 1/3 of that 3, and it leaves me with 16 pi units cubed. So I can see this is the winner, that that one across the x-axis has a greater volume. And you can also see the reason why it has a greater volume is because its radius, whenever we squared it, was a bigger number. The radius on the one for the x-axis was 4, whereas the one going around the y-axis was just 3. So when we squared that number, it got bigger. The end.